Hey, seventh grade. So our learning target today is I can make and interpret histograms. So let's start by talking about what is a histogram. A histogram really is like a bar graph that shows the frequency of data values in intervals of the same size. So kind of is similar to a bar graph, but what's different about them is these little numbers that are down here, which are called intervals. So these numbers down here are what make histograms and bar graphs a little bit different. So it is a bar graph, but it has number intervals. So instead of just saying how many people chose red as their favorite color, there's a range of values, but they all have to be the same size. So the range of this one has a range of 10 points in each, 0 to 9, 10 to 19, 20 to 29, and so on. That's the interval of 10 units. So what are the steps to making a histogram? So you don't have to take any notes on this part. I have this kind of labeled for you. First, you have to draw and label the axes, just like you would for a bar graph. And then you're going to have to draw a bar to represent each interval. You would have to set up the intervals just like this, equally spaced intervals. Okay. So example 1, here's our first example of a histogram. So first of all, we need a title. So we're talking about, it says, the frequency shows the ages of people riding a roller coaster. So we're going to talk about the roller coaster. Okay, I'm using one of the tablet pens, so it's a little bit messy. Sorry about that, guys. And then we're going to talk about, in this problem, we're going to talk about ages. So we're going to go ahead and put the ages down here, ages. And the ages, you can see range. They have a 10 point range here. It probably feels like 9 to you, but really if you were to count that off, the digits 10 through 19 is a 10-point range. So we're going to start by saying, and I like to do these diagonals, ages 10 through 19. We have ages 20 to 29, ages 30 to 39, ages 40 to 49, ages 50 to 59. Okay, so then our frequency would be over here, which means the number of riders in each of those categories. So how many riders were in the ages of 10 to 19 and so on, which is what makes it a histogram because of the frequencies or the range of numbers. So I'm going to just arrange by twos. Now my writing's going to be kind of small here because of the space, but 2, 4, sorry about this. Hang with me here, guys. 2, 4, 6, 8, 10. It'd be a lot better if I was writing on the smartboard right now, but 12, 14, and 16. Okay, so we're gonna scale by 2. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so when I look at my data here, the number of riders in the ages 10 through 19, we had 16 riders in those ages. So we would go ahead and follow it up to 16 and follow it down. So we would then do this bar graph up to 16. We had 16 riders ages 10 through 19. Go ahead and fill that up. That's just a bar. All right. Then 20 through 29, 11 people. 11 people through 20 through 29. So we have, this is 11, approximately 11, and we're going to follow it over and down. We have 11 people, range 20 through 29. All right, and then we have 5 people, range 30 to 39. 5 people, range 30 to 39. So we have 5 people ranging 30 to 39. If I'm going too fast, go ahead and pause that video. So again, it's just like a bar graph. What's different is the interval, the ranges on the bottom. We had only 2 riders, 40 to 49, which probably doesn't surprise a lot of you because that's kind of the time frame where maybe people aren't interested in riding fast roller coasters anymore. However, it hops back up again, ages 50 to 59. And those are people that maybe are riding on with their grandchildren, things like that. So 50 to 59. We have 4 riders there. And again, it's kind of hard to estimate where that is because we just sketched the graph, and this is what's called a histogram. So it's a bar graph that has these ranges of data on the bottom. Some key things is that the bars have to touch. Notice in my bar graph, all the bars are touching each other. That is super duper important in a bar graph. Make sure that you've created that way. Okay, so that's how you make a bar graph. You're going to be asked to do that in your homework. Before we move on to homework, I'm going to ask you to turn to the next page and let's talk about how we interpret a bar graph. So we already just talked about how we make one. The next goal for today is how we interpret one. So you can see the ranges are on the bottom. These are speeds at the Daytona. and these are the people that won the race. So very few people won the race here in that low speed range. Most of the winners are coming in the 150, 159 range. So let's ask these questions. How many of the winning speeds are less than 140? Less than means not equal to. So we're really talking about, so if we put an estimation here that looks like it's about 1 out of 4 there. This is 4. This is 14, 19. This is 7. And this is 4. So how many of the winning speeds are less than 140 miles an hour? Well, here's 140. There are the winning speeds. So we'd say 5 is a less than 140 miles an hour. 5 of the winners. We're not traveling all that fast, actually, which is interesting. Maybe a crash happened. Maybe they just paced the race better, and so on. Which interval, so which range has the most data values? Clearly, this interval here has the most. That's the longest bar. So the interval for that would be 150 to 159 has the most. 150 to 159. All right, so how many of the winning speeds are at least 160? So 160 and more. How many? So here's 160 and more would be all of these. So that would be 11 of them. And then could we find the mean, median, mode, and range? Could we find the mean? No, because you'd have to add up the individual data values and divide. The problem is we don't know individual data values here, so we couldn't find mean, median, mode, or range. We can't find any of them. We can't even find the mode because we don't know the individual data points. We know the range where most of them land, but we don't actually know the exact speed. The speed could have been 154 miles an hour and 155 miles an hour and so on. So can you find those? No. We don't know individual speeds. We just know the range in which they fall. Whoops, I spelled that wrong. Sorry, guys. Individual speeds. We do not know individual speeds. So we couldn't calculate those. We couldn't calculate mean, median, mode, range without the individual data values. So it really just gives us kind of an overall idea. That's what histograms do for us. Give us an overall picture of where the fastest racers were coming in. Okay, let's move on. The histogram shows the number of hours that students in a class slept last night. How many students slept at least 8 hours? That means 8 hours and more. So that's all of these students and all of those students. Looks like 8 in here. And this is looking like a data value of 3. So at least would be 11. It's looking like 11 students slept 8 hours or more, those top bars. How many students slept less than 12 hours? Less than 12 hours would be all of these, because here's 12, less than 12. All of these, which is 8, all of those, which is 2. So these students right here slept less than 12 hours. 8 plus 8 is 16. 16 plus 2 is 18 students slept less than 12 hours. All right, here we go. Let's finish this up, guys. It's kind of a short lesson today, so that's kind of exciting for you. Which graph is a histogram? You should be saying test scores. The reason why is that the bars have to touch in a histogram, and you have to have these range of values. Bars have to touch, and it has to be a range. This is called a bar graph. So just be aware that they're both bar graphs. They both have bars in them, but histograms, the bars have to touch and there has to be a range of values. Describe the outliers or the data that doesn't fit in the histogram. So looking at the histogram, the data that doesn't fit is that little tiny bar. It's kind of off on its own. That's called an outlier, or you could think of it like an outcast. That range of data values just doesn't really fit where the other bars are, and there's that huge gap in between. An outlier is something that just doesn't fit, like an outcast. And our last question for our classwork today, how can you tell when an interval of a histogram has a frequency of 0? So this one right here, if I go back over and erase this, so you can kind of take a picture, a frequency of 0 would be this one right here. This is 0. And that just means that you wouldn't see a bar. No bar exists. That means it's a frequency of 0 when you don't have a bar. Frequency is 0. So that's our lesson on histograms. Remember, they're kind of like bar graphs. The bars have to touch and you have to have a range of values. Your homework from tonight is pretty fast homework. So you might have some extra time today in class. Real short, fast homework. Homework is on page 7. That's all we have for histograms today. Have a fabulous night, 7th grade.